Hello everyone, we are Team Rite-Solutions AutoML Ship Classification in a Box. Our project is utilizing AutoML for standalone ship classification systems. Our technical directors are Thomas Santos, Chief Technology Officer, Chuck Angel, Senior Systems Engineer, Akintoye Onikyo, Software Engineer, and Ken Harlow. Our team consists of one electrical engineer, myself Nathaniel Trazi, and one computer engineer, James Chen. Rite-Solutions is a veteran-owned small business, headquartered in Middletown, Rhode Island. Established since April 2000, Rite-Solutions has over 250 employees, with core competencies including software engineering, software development, information technologies, and cyber engineering. Rite-Solutions is known for their innovation and dedication to the information and decision support needs of our government and commercial customers, a commitment they have coined as a company slogan, the information advantage. Rite-Solutions has a significant U.S. Navy prime contracts in both warfare systems and business systems development and sustainment, as well as information technology, infrastructure support, and cyber protection. Project motivations. Using a cloud-based system, namely Google Cloud AutoML, Rite-Solutions successfully trained a ship classification machine learning model with a ship-labeled dataset to identify and categorize ship images, such as the type of ships and whether they are friendly, a threat, or commercial. Although this approach is successful, cloud-based solutions are not a viable approach for customers in situations where network communication to the cloud does not exist or are bandwidth limited. Additionally, public cloud solutions present a security problem when the sensitivity and level of confidentiality of the data cannot be ensured and adequately protected. Our anticipated best outcome is to research, identify, deploy, configure, and test an open source AutoML implementation that can be used to support ship classification. Research and recommend a standalone AI system that can support training of machine learning models in a standalone environment. Design and develop a standalone device that incorporates an AI hardware accelerator for the use in an edge computing environment to support machine learning model execution. Our anticipated best outcome has been achieved. We were able to utilize an open source AutoML solution in the standalone environment to train and classify ships, as well as perform inference on multiple edge devices that support ML models. The picture on the left is a Raspberry Pi with a Coral USB accelerator, which enables high-speed machine learning inferencing, and a successful inference of a class type DDG Burke on the right. Economic impact. Achievement of the best anticipated outcome will create efficient image recognition tools that will be able to rapidly and accurately identify threats while deployed in production, commercial, and U.S. Navy systems. Additionally, the application of these tools are very versatile and could have multiple applications. For example, recognizing undersea objects for oil and gas exploration to accurately assessing forest density as part of a wildfire prevention. Overall, with a proven solution, Rite-Solutions will find ready markets to provide and integrate ship recognition solutions into existing Navy and commercial platforms. Key technical accomplishments over the spring 2021 semester. Train deployable ML models, installation and testing on the Dell AI Workstation, inferencing ML models on edge devices with Coral USB accelerator, and both the NVIDIA Jetson Nano and Xavier. Project overview. In the first step, Rite-Solutions curates data to create and label datasets. Next, using an AI workstation to train a ship classifying ML model with a ship dataset. After the training is complete, the next step is to test the ML model for accuracy and capability to the edge device. Finally, export the ML model to the edge device for ship classification. AI Workstation. Over the past fall 2020 semester, I spent a lot of time looking into the AI Workstation to be purchased for deep learning opportunities. After finalizing a purchase with Dell for the Dell Precision 7920 workstation, Rite-Solutions was able to set it up in their office once it arrived. After the workstation arrived, James and I needed a way to access the workstation, and due to COVID, we were not able to go on site to Rite-Solutions. So the team decided to lend James and I company computers to VPN into the workstation from our houses. This was the perfect idea to get James and I working within the workstation to get it ready for training. The first task at hand was to install AutoML platforms. For example, Anaconda and TensorFlow. After installing and testing the AutoML platforms, James and I were able to train within the workstation and carry over our trained models to our single board computers. After researching for the perfect single board computer during the fall 2020 semester, our team at Rite-Solutions decided to go with the NVIDIA Jetson Nano along with the Jetson Xavier. The Jetson Xavier being the big brother to the Jetson Nano with more power and more capabilities. But both would have the same fundamental background and operating system, meaning if we were able to run one model on the Jetson Nano, that same model would run cleaner on the Jetson Xavier. After walking through the setup of the Jetson Xavier, James and I were able to take the model we ran on the Dell workstation and implement it on the camera with a camera on both Jetson boards, reaching our anticipated best outcome along the way.
Along with discovering the best workstation, we need an automated machine learning solution, which is to automate some or all the steps of the machine learning process easily. In order to select the most suitable option, open source AutoML tools are researched, identified, and evaluated through a Pew Matrix methodology and supporting criteria. The Pew Matrix, when used for decision making, helps us select the best viable and most feasible option from a list of given alternatives. To help select from the list, there are criteria the matrix utilizes that factors in each tool's strengths and weaknesses, as well as ability, to determine the best solution to use for the project. The criteria for the AutoML Matrix included AI workstation compatibility, the ability to detect objects and images, the ability to classify images, saving and loading models for inferences, ability to train with the GPU, and more depending on the need of determining factors. Once we had completed our Pew Matrix, we were able to evaluate that AutoKeras would be our first alternative open source AutoML tool, and AutoGluon to be our second choice. Every AutoML tool is accompanied by developing a Python script to enable training on a dataset of ship images. The script includes loading the dataset of over 800 ship images with 8 different types of ships, and splitting the dataset for training, validation, and testing. Then utilizing the AutoML tool, the model undergoes the training phase, which uses the images in the training and validation datasets. During the training phase, there are parameters that can be changed that affects the overall accuracy of predictions on the model. Some training parameters include image modifications, epochs, which is the number of iterations through the training dataset, and the batch size, or the amount of images per iteration. Since we were limited to the amount of images to use for training, we had used the image modifications to include copies of the training images. Modifications could be flipping the images, zooming in, and translating the images. Keeping in mind that the training data is important to predictions, we had kept the modifications as realistic as possible. For example, flipping the boat images horizontally and not vertically. After the model has finished training, it is evaluated with the testing dataset to get a result of how accurate the model may perform during prediction. If the accuracy is not sufficient, we can retrain it and change the image modifications or the epochs. At this point, the trained model can be exported as a compatible file format for an edge device, and we can classify any images as an input. Our final trained model achieved an approximate 75% accuracy in predictions, and could accurately classify 85 of the 112 ship images of our testing dataset. With the progress we made both semesters, we were able to achieve our anticipated best outcome. To demonstrate our achievement, we have created a demo video of the Coral USB accelerator performing the inferencing process with the model we have trained using the AutoML solution. In this demonstration, a camera is attached to the Raspberry Pi and is pointed to an image of the ship to be classified. Once the ship is in frame, the blue button on the Pi can be pressed to capture the image to perform inference. So here is an image labeled as Chinese being classified. And then the target's type was also predicted to be Chinese, which is correct. Each inference will take approximately 500 milliseconds for the classification results to be revealed, and consecutive inferences can be performed in a row. And with that, we would like to thank our technical directors for this opportunity and continued support. Thank you.